Hi, good morning, good evening, good afternoon. This is Mike from Unknown Tech, and welcome to the Architect Podcast. This is episode 23, where we'll be focused on agentic AI and observability. So that seems to be the big topic of discussion as of late, as I go into the enterprise and talk about their AI initiatives. Customers are moving, I wouldn't say moving towards, but adding on, right? More agentic or agentic AI use cases, excuse me, as it pertains to their business. And there's this kind of not argument, but discussion that's happening in the open on LinkedIn. If you follow and read a bunch of these posts from different providers and different SaaS vendors and agentic AI solutions, there's just so many out there. There's just an explosion of information, and there's two key areas I think that customers are having, everybody's having really a conversation about when it comes to agents. And the first one is, how much autonomy should we be giving agents? That's the first. And the second is, do customers really want autonomy at all? Right. And I think that's a big ask for a customer to say, I'm going to give autonomy to a system, right, that I have, that I really need to maintain full control of. Now, of course, as humans, right, we have autonomy to do things in our daily jobs, right? And so when you look at the IT organization within an enterprise or any position for that matter, there is autonomy given, right, to do specific tasks, right? We expect that you're trained, you know what you're doing, and that you follow guidelines and principles and ethics um, and policies and all of those things, right? So you don't break those things, and you just do your job, right? You complete your job to the best you can do. And we kind of expect the agent to do the same thing. The problem is it's very hard to do that. And so what's required to either give an agent autonomy or build autonomous workflows, meaning the outcome should be automated and customers, looking at, autonomous outcomes, not autonomous agents, so to speak. And so what is required for that? Well, what's required is a complete stack that gives you full control and visibility. Okay. And now what I will say is that the things I'm going to show you today, right, are not productive. It's basically looking at are the possible and you should be looking, right, and how you should be looking at things when it comes to agents. And as a matter of fact, the agent I'm using, more than likely, you won't even be using in an enterprise production scenario. Okay. I have a very small lab. I'm going to talk about the lab, how it's built. I'm going to talk about the layered platform underneath a little bit. I've already done this in the past, and I'll show you a little bit on where you can go to find information out and see previous episodes that walk you through in detail of the stack, right? And then today I'm going to be demoing using the agent and actually getting visibility into what the agent is doing, okay? And we're going to be using a tool called Langfuse. Some of you guys may have heard, or gals may have heard, tools like Langsmith. That's more of a SaaS offering, and that's probably more where customers will kind of point to. Langfuse is as an open source version. That's what I'm using today. So it doesn't have the full capability. And I actually had to do some things, excuse me, I actually had to build a proxy with Fast API to actually get this working, because what you're doing is you're intercepting the traffic, the request of the agent. So it hits Langfuse, right? And it goes off, and then it can forward off to your model endpoints, right? And then receive that information back and then log it so you can have observability, tracing, token visibility, governance, cost visibility, all of those things within the Langfuse solution. And because, look, I think that there's not going to be this one, as much as everybody wants to say we have a full stack AI platform, the reality is there needs to be integration. It's just like with anything, right? And I look at this from, if you go back, and even if you're not in AI and you're learning AI and you're just attending to get more visibility into AI, if you're an infrastructure team or you're a platform team and you're not doing anything with AI, or you're not responsible for AI right now, I wouldn't say not doing anything with AI, because I think that's probably not true. What I'm saying is, if that's not your primary focus, right, you still are inherently implementing systems, right, and platforms that are not just one vendor, right? They're not single vendor, unless you're in the cloud. And even in the cloud, I'm seeing customers leverage tooling, right, that maybe AWS doesn't provide a robust tooling system for, or the customer, and this is more the reality, or the customer's running in a hybrid fashion, and they want to use the same tooling across on-prem, cloud, colo, edge. Okay, and so it gives them that unified way of doing operations. The same thing applies with AI, right? There's not going to be this one thing. Oh, I'm going to use this one thing. It's going to provide me everything. All right. Or it can provide me everything, but maybe the features within the platform aren't as robust as me using a third-party tool and integrating that tool within my platform. And that's what I've done today, showing you this platform. Okay. So it's going to be, I'm going to try to make this an hour. I'm going to try to get you out of here at noon. But I want to just go through what it is I'm going to be talking about today. So, oh, hang on. Let me just go here, share my desktop. And let's go into what I'm going to show you, okay? So essentially, what I have stood up is I have a lot of time on it, because again, I'll show you where you can go get information on. Essentially, I have a Hermes agent, right? And I'm using Hermes because I find it much more better for what I do than OpenClaw, as an example, right? Hermes does self-learning through looping and all of those things, right, to get smarter and smarter over time, which I really like. The gateway services are going to be provided through Nutanix Enterprise AI. I'll talk more about what that looks like. There is a proxy. It says NAI proxy. It's not. It is an NAI proxy, because basically what I'm doing is, the first thing the Hermes agent hits is this proxy I had to build. So you're probably asking, well, why did you have to build it? Why didn't you just use something like Light LLM as an example? So I tried to use Light LLM to begin with as the proxy, and it didn't work out because it only supported V2 APIs, and Langfuse is using V4 API. And so it became a nightmare trying to get that working. And so the easiest thing to do was to use Fast API and create, and by the way, I vibe coded this, right? I didn't create this myself. I'm not a developer by trade. We vibe coded through Anthropic and using Cloud Code, a proxy, very small proxy. I think it was like 60 lines of code to actually forward the traffic on to the gateway, right? And also proxy the connectivity into Langfuse, right? So it can actually capture everything the agent's doing, right? And all this is running on the Nutanix Kubernetes platform, on the Nutanix Kubernetes platform, on the Nutanix Cloud platform, which is the foundational infrastructure underneath. And the accelerated compute is provided by an NVIDIA GPU. And it's really running in a small form factor system, right? It's very small. It's an MS02 Ultra from Minisforum. It has 192 gigabytes of RAM, 6 terabytes of NVMe, as well as an RTX 4000 SFF ADA, which fits within that small form factor system. Very small, very efficient. The RTX 4000 SFF ADA only uses 70 watts at max of power. That's 20 gigabytes of VRAM. The only problem with it is really the memory bandwidth. Okay, so if you're looking at building something like this for your lab, don't expect this great performance. Don't expect very fast performance. Don't expect like this massive tokens per second, right? It's not what it's made for. It's built for POC, proving out, can this be done, or how to do things, or integration and things like this, okay? So this is what the architecture high level looks like, right? It looks like the Hermes agent, which is running in on Nutanix Kubernetes platform, okay? One thing I didn't show you here, there's also an MCP server running. I'm going to talk about that because that's important too when it comes to governing what my agent has access to. Okay, Nutanix has some built-in tools with Nutanix Enterprise AI that allows me to kind of only allows certain specific access using that MCP server. And you can see here this proxy using fast API, and then proxying the tracing and the information into Langfuse, and then forwarding that on to the NAI gateway, which is providing the unified endpoint. Now, the gateway within Nutanix Enterprise AI is set up to point to OpenAI GPT-4o Mini as the primary, and then the failover goes to a locally hosted Qwen model, which I'll show you here in a little bit. So the observability stack really is a combination of using Kubernetes, using Nutanix Enterprise AI, and using Langfuse. And Langfuse is getting more into the API calls, the traces, the context, the token utilization, usage, the tooling access, the cost, all of that. That's what Langfuse is doing. And so we're sending basically every message. We're getting a full response. You can see that full response in plain English or natural language, or you can see it in JSON. We're capturing token counts, latency end to end, which is extremely important. And we're running on this on a very small lab, which I'll talk about here in a little bit. Okay, so that's kind of where we're at here. Before I get into that, really quick, I did a LinkedIn post on what is the AI stack and what does that look like, right? So I'm going to make this bigger so you guys can see it. But essentially, right, it's Jensen from NVIDIA talks about the 5-layer cake. This is similar to that, except it's a little bit more in depth on the AI platform. I'm not including power, cooling, none of that, right? Or the AI apps themselves. What I'm including is what does it take to really deliver an enterprise AI stack? And when I say enterprise AI stack, I mean a hybrid AI stack, because that's where we're heading. Just like with cloud, we're heading to a hybrid model where you'll be consuming both on-prem AI stacks as well as service provider, neo cloud, or hyperscaler stacks. Again, example would be Anthropic's Claude, right? Neo cloud could be something like CoreWeave. The third could be a hyperscaler like AWS, using Bedrock as an example. Okay. But at the bottom layer, right, you have your infrastructure, right? That's your accelerated compute. And when I say accelerated compute, it's just compute with acceleration, which is GPUs, NPUs, et cetera. They could be ARM, could be x86, could be AMD GPUs, could be Intel CPUs, could be AMD CPUs, NVIDIA CPUs, NVIDIA GPUs, and a combination of offloading technologies, right? Like NVIDIA's Bluefield or AMD's Pensando DPUs, ConnectX-7 from Mellanox, right? And using these offloading software technologies like RDMA, like NVLink, like SRIOV, right? All of those things utilized together to give you this fully capable networking that is required when it comes to scale out inference, especially when you start looking at cluster to cluster, cluster with intra and inter-cluster communication for scaled inference, scaled agentic inference. Okay, and then running on top of either bare metal, right, on using Kubernetes, or using a hypervisor that can give you bare metal performance that's topology aware. And this is something I think is extremely important that we're not talking enough about. Okay. You can go and you can run this on bare metal Kubernetes. The problem that we're seeing with this is that Kubernetes is extremely bad at understanding NUMA boundaries, PCIe boundaries, PCIe mapping to CPU, memory mapping to CPU, all of those things. And so what's good at that and what's naturally good at that is virtualization. Now, you're probably thinking to yourself, well, Mike, if I add a virtualization stack in this, right, I'm going to now have overhead, and that's going to cause me additional latency, additional performance implications. So you're correct. Natively, virtualization would do that, right? But we are delivering at Nutanix, again, I don't want to make this a sales pitch, but we are delivering a topology-aware hypervisor with HV that gives you very, very close, if not bare metal performance, as well as giving you topology-aware hypervisor, which can then be delivered back to the Kubernetes layer. Okay. And so now I can segment my nodes, my Kubernetes nodes, into virtual machines that are topology aware, right? And can be used for more, as you build your AI platform, you're going to have more customers consuming it. And so you're going to be able to segment your environment, right? Through more service, like a service provider model. I don't want to say that, more like a multi-tenant. Let's call it that, right? Could be service provider model, could be a neo cloud, could be something else, but in the enterprise, right? It could be different groups within the enterprise consuming the AI platform, and therefore you want to segment those pieces of the AI platform and prioritize what's needed for those different groups, whoever's paying for what, okay, and for what project. And so that's what I'm talking about when it comes to infrastructure. Next, you have the data services, extremely important. It's, to me, data service is a combination of storage and data services. Okay, so you have storage, the underlying infrastructure that the data services run on, and what is required for that: high bandwidth, low latency, RDMA acceleration, GPU direct, right? Using tools like solutions like PFNFS, hardware accelerated objects, right? All of those things for many different functions, right? Databases, unstructured data, KV cache offload, all of those things. But also, using something like Data Hub, which is a roadmap item from Nutanix that's going to allow you to give you a Databricks-like solution on-prem, where we're bringing AI to the data, allowing you to do data curation, right? Getting your data AI ready and then delivered back to a vector database as an example, right? That's what I'm talking about with data services, all of that. And then you had the orchestration layer, which of course is the Kubernetes platform. We provide Nutanix Kubernetes, right? You can run any Kubernetes on our stack, but we have a solution already. And there's no separate AI cluster silo to bolt on or manage. It's included, and it will support ARM eventually here soon. You can run on bare metal, or you can run it on topology aware AHV as an example to give you that more robust solution. And then you have the partner software, which we talk about NVIDIA AI Enterprise, right? Because that's the most popular, right? Because they have CUDA, and CUDA really is the moat for NVIDIA, right? It's not just the silicon, right? It's really around CUDA. And the fact that CUDA has been around for 15 years, it's mature, right? Developers understand it, they know how to use it, et cetera. But at the same time, customers don't want to be locked in like they were locked in with all these other providers, right? With other solutions like, Broadcom as an example. They want choice, right? So AMD has Enterprise AI Software Suite and ROCm, and we're seeing ROCm come out of the gate to support modern frameworks like VLM, all of these things, right, to make it easier and giving you another path or another option. And so what I mean by that is, more than likely, you won't just have NVIDIA, you'll have a mix of things. You'll have CPU inference in some cases, right? Intel has AMX offload. Venice CPUs will be coming with offload as well. Typically, as long as you support AVX 512 and CPUs, you can do some offload when it comes to, some processing when it comes to inference. Of course, that'll be for more minor use cases. But CPUs will be very important, especially multi-core CPUs that are very efficient to do agentic tasks. When you start looking at your agentic workforce and you start scaling that, agents will require CPU to do all of the things other than the brain things, the reasoning pieces, right? And what I mean by that is, all of the tool calls, all the scripting, all of the things that CPUs are built for, the serial IO tasks, right? Whereas the reasoning, all that inference, all the things, right, for the agent will be done at the GPU layer because of the parallelization, right, that GPUs provide in the stream processors, tensor cores, et cetera. And then you need an AI platform to bring this all together. How do you bring this all together? I mean, I've seen a lot of different customers build some of this, and I hate that they've done that because they're spending time on building instead of time on the value side of it, right? And that becomes overhead. And so you need to have a solution that layers on top of all this, where you can quickly consume and get to value quicker. Okay. And so I'm going to talk a little bit about some of this here, because we'll be spending some time within the enterprise AI stack, and I'm going to show you what I'm talking about. Okay. So let me just go back here, make sure everything looks okay. Okay. Now I'm going to be going to, just bear with me a minute here. Yeah, this should be playing. Okay. All right. So, and I have to have music in the background or else my headset will time out. I know it's kind of a janky thing to say, but that's kind of where we're at. So let's go into just quickly what I talked about. I'm just going to log into the infrastructure side of things really quick. Oh, and I'm basically logging into Prism Central, which is the consumption layer, the API gateway and the consumption layer for Nutanix Foundation. And you can see here I have a cluster here called Source, okay? And this cluster is basically running on an MSO2, right? I talked about this, the minis farm. It's very small. It's probably about this big, but the size of an encyclopedia, a little bit bigger, a little bit thicker than that. And it fits right in my rack. If you guys want to see this information, right, you can go to my blog. It's unknowntech.io or unknowntech.wordpress.com. And you can go through my blog posts, or you can look at all the live streams I've done in the past by clicking on live streams and podcasts. And if you scroll down to the portable agent platform, go to episode 21, where I go in depth on what this looks like, and episode 20, excuse me, both 20 and 21. Okay. Essentially, I started with OpenClaw and then I transferred to Hermes. And I like Hermes much better. And then this episode will be episode 23, and I'll upload this later for you guys to go back and watch it. But essentially, if you look at episode 20 and 21, you'll get a sense of what the actual infrastructure looks like underneath. I talked a little bit about that a few minutes ago. But this is the software-defined platform, right, that's running on top of that infrastructure. You have the Nutanix platform, which can run VMs, can run Kubernetes. It runs my storage services, right? So I'm using unstructured storage services. I have a filer in here called Xion Vault. Everything is named by the matrix, by the way. That's why you see Xion and Neo and the matrix, right? All of these things, right, was based on the matrix. Because I just watched the trilogy again because I just loved it, and I haven't watched it in years, so I wanted to watch it again, and so I just recently watched it, and I went back and said, you know what, I'm going to use the names in my lab. So this is my NFS solution. It's providing read-write many storage PVCs back to my Kubernetes platform, okay, as well as other things, okay. And then again, you had the infrastructure, you have the Kubernetes layer, right, which is, you see Morpheus. This is the Kubernetes platform. And you can see here it's only 3 nodes, and you can click on the nodes to see the VMs. And one of those nodes is a GPU node, of course, right? And it's using the NVIDIA RTX 4000 SFF ADA, as you can see here. You probably can't see this. I'll make this bigger. Okay. This is just the 3 VMs, right, that are supporting the Kubernetes platform. Okay. And you can see here how they're set up. Again, this is not a production-ready Kubernetes solution. I only have 1 control plane and 2 worker nodes. Okay, that is it. And generally speaking, you won't set it up like this. You'll either have 3, right, 3 control plane nodes, right, for etcd quorum and failover resiliency, and you'll have typically 2 or more worker nodes. In the NAI deployment, you're going to have the NAI control plane side of it. That'll be in as a separate cluster, and then you'll be adding either clusters for worker nodes for GPU, or you'll be adding worker nodes to that. Typically, you want to add a separate cluster. There is a new NVD, which is the Nutanix Validated Design for AI. I'm going to be covering that in the next podcast. I'm going to go through that in depth and walk through that with you. Okay, and that's what production-ready Kubernetes platform will look like with our partnership with NVIDIA, okay, on that. And we'll talk more about that. AMD will follow here soon, and you'll see a similar NVD with AMD GPUs as well, okay? NVD is like it's not a reference architecture, it's a validated design, okay, that we actually test, validate at scale with different software versions, levels. We get partner integration and work with the partner on it. All of those things to make sure that when it's delivered in your environment, that you get the expected outcome, right? And that's the value of the NVD, okay? You can see here I have storage. Like, what's the storage? So I have block storage, and I have unstructured data, right, for files that I'm using PF or NFS, right, in the filer I just showed you. And I also have block storage that's natively within the platform itself. Block storage for the filer here, right, and block storage for some of the PVCs that are required, the read-write once PVCs that are required for my Kubernetes stack, right? I do have a full stack Kubernetes solution. It's NKP. It's running here. You can see this. This is the Kubernetes layer. I only have one cluster. It's called Commander Host because the initial cluster that you stand up, generally speaking, with NKP is the management cluster. And what I've done is I've just reused the management cluster because I have very limited resources. If I go back to Prism Central and I go back to the home screen, look at the memory utilization I'm using just with those 7 or 8 VMs. Right, I'm memory limited on this environment, and really, I could support 256 gigabytes. I only have 192 gigabytes in this environment. I really need to go to 256 to give me some comfort here. Right now, I'm running at 95% utilization. Okay, CPU is underutilized, right? But I'm memory limited. Okay. So again, this is the cluster. I can drill into the cluster and give you guys an idea of what it looks like. I'll go into the node pools and show you here. We have one control plane node, one worker node, and one worker node for GPUs. Okay. So basically what I have set up here is I have the worker node running all the control plane workloads for NKP, as well as the NAI, which is the NAI platform, the AI platform Nutanix, running on this worker node as well. That way the GPU worker node is only resourced for the inference, right? For the endpoints, all of that. Okay. And if you go in here, you click edit, you can see what I'm using here. And in my case, I'm using Ubuntu 2404, right? It's got this configuration. And you can see here the GPU mode is none. And the reason why that is because I'm using an unsupported GPU. So I had to do some finagling to get that working. But it really is running a pass-through. And you saw that on the node, right? Pass-through GPU to this node, and you'll see it when I go to the Kubernetes layer. Okay. And then in the AI layer, right, the NAI, I have the Nutanix Enterprise AI dashboard here. Okay. We'll be talking most about unified endpoints and MCP connectors. And you can see here, I can get all the metrics of what's happening within my environment. I can do model management. You can see here, I've downloaded models. I connect back to Hugging Face, or I can import from, NVIDIA NGC if I want to, or I can upload my own models or models that I've downloaded and fine-tuned as an example. This gives me full model access control. You can see here I have an allowed list. I'm only allowing the checkbox, right, versions. You can see here, I'm only allowing these. And the ones that are not allowed, what happens is you'll see that within this, you'll see this, right? So Gemma 2 BIT is not a model that is allowed. It's restricted. And so I can't even create an endpoint from this. It won't let me do it. Okay. And so this gives you complete model operations within your environment for your users to either allow specific models or deny, or both, right? You're basically doing both, right? You're allowing and denying access to specific models. And that's really important to your security folks and really important to your organization as a whole, because you may not want to allow DeepSeek in your environment, or Quen. I'm using Quen. You may not want to allow Quen. Quen's a Chinese model. You may not want to allow that in your environment. Okay, so you have to be very clear about what model access you're going to give your AI developers, right? Your AI agents and your AI platform engineers. Okay. The inference framework is really around endpoints and providers. Okay, so before I get into the endpoints, I'm going to talk about the providers. In here, I can add many different providers. Okay, from Anthropic, AWS, Azure, GCP, or Nutanix Enterprise AI, right? Which is your local provider, right? Which you would use with Nutanix. I'm actually using both. I have OpenAI. You can see here I have an OpenAI provider already stood up, and I have a local endpoint configured. You can see here is active. Okay, and it's using my RTX 4000, and it's just a small Quen 3.5 model because I can't fit much bigger onto the RTX 4000 with a large context, because I want to have a larger context for my agents, right? For my Hermes agent. So we can go in here and get the metrics on this, right? As the API keys that we've created have access to, gives you the URL that you need to access this, right? And you can test it as well. So we give you a specific sample test or a custom test. So tell me about NVIDIA, right? So you can test it and make sure it's working. You can see here it's working. Okay. And it's a reasoning model, it's a small, model, 9 billion parameters. I believe it's a I didn't look, but I believe it's a 4K. It's quantized to 4K, right? So I try to use smaller models like that because I'm not interested in accuracy through my testing. I'm interested in capabilities and how I can test validations and integrations, right? I'm not so much interested in accuracy. You guys at the enterprise level should be really interested in accuracy. Okay. Now, I do have an NVIDIA DGX Spark sitting in my little rack here on my left-hand side. You can't see it. I will be selling that because what I'm going to do is I'm going to buy an RTX 5000, probably a 48 gig version, because that 48 gig version is going to give me enough memory to at least get me into a 37 billion parameter model, 35 billion parameter model, which is kind of the sweet spot these days, it seems, and still give me enough memory for a larger context. So I may be going to that and going back to my main lab, right, into my data center, I call it my data center, into my other house in New York, right, in my basement. And so I probably will be moving to that and selling my DGX Spark. The DGX Spark did what it did. It did very well. I haven't really decided on that yet, but essentially I'd like to get better models because this 9B model isn't great for agents, right? Would be great for small use cases, tool calling, small things, right? Those types of things, but it's not great from a capability perspective. Okay. Then I have unified endpoints, is what we'll be using today. And so a unified endpoint allows me to leverage other providers outside of my data center, right? And using something like a GPT-4o Mini. Remember, I had that provider out in my setup, in my environment here, OpenAI. So now I have access to all the OpenAI models in the back end, right? And so in my case, in this unified endpoint, I'm using GPT-4o Mini, right? It's cheap. That's why I use it. And I'm failing over to the Qwen, the locally hosted Qwen model on-prem. So if something happens with network connectivity out to OpenAI, I can fail over to the Qwen model and still be able to work locally, okay? Now, one thing that I haven't set up here is I can actually enable a global rate limit on token usage or a per API key rate limit on my APIs. So if I wanted to manage a rate limit in the OpenAI model, I can do that. Or I can say, okay, this token on the GPT-4o Mini, I only allow 50,000 tokens a minute. Okay, and I can save that. And when I do that, right, it's going to fail over when I reach my limitation. Okay, so this is another way of controlling token utilization. And I know a lot of customers I'm talking to, they're getting hammered with token costs right now because it seems like every provider model that gets released, right, their token costs go up exponentially, 5x, 10x. I just talked to someone the other day at a large financial, who said that when they went to Fable, and I know Fable's been taken down. I won't talk more about that, but when they went to Fable, their token costs went up 5x to 10x, right, on token costs. So, the more powerful the model, the more accurate it is, the more tokens. Okay. And so you kind of weigh these things, right? You can't just be out there just blowing through tokens, because at some point it's going to be like the cloud. You're going to get that bill and you're going to be like, oh, I didn't know it was going to be this much, or we didn't budget for this, or more importantly, what value am I getting out for the money, for what's my return on investment, my ROI from this? Someone on LinkedIn the other day said the easiest way to test value for your AI projects is to remove access remove model access, shut it down for a time period and see what happens. I think that's ingenious, actually. So, that'll determine whether, your users are really using AI and getting value out of it, right? You may get people come back and say, hey, I can't access this, right? But accessing something is not what value is, right? If I can access GPT-4o Mini, if I'm not getting value out of this, what is the value I'm seeing? What's the outcome? That's what you have to get to, right? You have to understand that. Okay, so the unified endpoint is going to allow me to basically route, right, traffic, right? I'm going to route it to GPT-4o Mini. It's an order 1, excuse me, and then I'm going to fail over to Qwen 3.5 if I have a network issue or something happens at GPT-4o Mini, I can't connect. Or if I had a rate limit on my tokens, I could route back to my on-prem model. And this is what it's pointing to. And so you can see here, we give you all the visibility into token usage, how many requests, how many failed requests, what's invalid. Okay. You can also look at other things, right? Especially in localized endpoints, you can look at, I'm sorry, let me go back here. You can look at your metrics. Okay. You can see here it's not being used, right? Because we're not using this. I haven't failed over. But for your API keys, for your different API keys, for all API keys, what's your request trend? What's your token usage? What's your cast token usage? You can look at the logs, okay, to see exactly what is happening in the logs, right? And you can see like average prompt throughput. So you're getting all this log information. We're feeding it back to you into NAI, meaning you don't have to go to the Kubernetes layer and do that. You can still go to the Kubernetes layer. You can see here, I'm logged into Kubernetes. And you can see, right, I can go into the logs and get the same information. But you may not want to have your AI consumers, right? You're not going to have them log into Kubernetes and go through a log. Or you may, another option is to obviously use a syslog component, maybe Splunk, and then give them access into that. But we're giving them access right into the consumption layer, right? Which makes it much easier, right? So, okay, let's see how this is set up in Kubernetes, right? So I'm just going to get out of here really quick. Let me close this window here. And let me make this bigger so you guys can see. And so I'm going to do, and I'm using an alias for kubectlk. So that's, if you wonder what I'm doing here, let's just do get pods Hermes agent. So in this environment, right, I have Hermes agent running in a namespace Hermes agent, and I have a MCP fire crawl with 2 replicas, right, for high availability. I know this is kind of moot because I only have Hermes as 1, right? But MCP Firecrawl is my MCP server for web searching, things like that. And I'm going to show you a little bit about how that's set up and how Hermes accesses this MCP server to actually do web searching. Okay. So I think that's important too. The other thing that we have set up here is get pods light LLM. Now, what you're going to see here is the namespace light LLM, because I'm just reusing this namespace because I tried light LLM as the proxy. It didn't work because I talked to you a little bit in the beginning about it supporting V2 APIs, Langfuse using V4 APIs. There was a lot of problems there. And so we just created a proxy through using Fast API. We vibe coded this, and it's using Fast API, and this proxy is running in the environment as well. Okay, and then there's Langfuse, right, which is the observability stack. So get pods, name Langfuse. Okay, and this is the Langfuse configuration. I'm not sure what happened here. I have to check this, the Langfuse ClickHouse. Okay. Hopefully it's working. I'm not sure why this is actually, you know what? Let's do that right now. So let's do a K logs and see what's going on with this. Namespace Langfuse. This was just working. Yeah, so I'm just looking to see what's going on with this. Wow, this must have never worked. Oh, Langfuse is working. Maybe, because there is some certain specific things in Langfuse that aren't working. But we'll figure that out here a little bit later. But you're going to get the idea of Langfuse here in a minute, and agentic tracing and those things here in a few minutes. Let me just make sure this is working here. Yeah, okay. Okay, so what we're going to do here now next is, okay, so you saw the architecture. You saw what we're going to talk about. I do have my Hermes agent tied into. I can actually I can interact with the agent through the CLI if I wanted to, but I'm not going to do that. It's just easier calling this out. I do have an agent, Hermes agent called Neo, and so that's already set up here within the environment, and that's connected back. Just so you're aware, it's connecting back to two areas here. All right, so it's connecting back to the demo failover unified endpoint. I'll say, okay, so as its reasoning model, its brain, it's using this endpoint, and it's using GPT-4o Mini at OpenAI, right, as its primary. And then if that fails, it'll fall back to Quen, which is the locally hosted endpoint here. Okay, now that's how it's configured. All right, I don't have any, you saw that I didn't have any token limits set up on the endpoint or the APIs. I could if I wanted, but I don't in this demo because I want to make sure everything goes through smooth so you can see the tracing and all that. Okay. And so it's using that unified endpoint. Let me go into the agentic tools and data though. So I do have the MCP server. Okay. You saw that in Kubernetes, and I have it configured within Nutanix Enterprise AI. Okay. So this connected MCP server basically allows me to now go in and create a connector. Okay. So I have servers, excuse me. Here's a server. This is the server URL. Okay, I'm not using a credential. You would use an API here. Okay, I don't have an API, or excuse me, a API key. You would use an API key to connect to this in production. I don't. So this is not good practice. This is just the demo environment. Okay, and you can see here I'm connected through this MCP server URL, which to this MCP server running on Kubernetes. Okay, now what this allows me to do is now create a connector. Okay, so what this connector is basically a go-between, all right, between the agent and the MCP server. All right, so think of it like I'm getting in the middle of the conversation, and because I'm proxying this connection from the the Hermes agent to the MCP server, I'm allowed to do specific things. Okay, so I created this connector. And what I'm allowed to do is go in here and select the tools that the MCP server allows me to use. So if I go in here and I hit edit, the Firecrawl MCP server natively gives me 3 tools within the MCP. It gives me scrape, search, and crawl. And I checked the box search to only give Hermes the ability to use the search tool within the MCP server. Okay, so you can see here what we're doing is we're basically interjecting the NAI tools, right? The NAI tooling here, the connector, within the path of the communication between the Hermes agent and the MCP server. And because I've done that, now I can now do specific things. And this is our first foray into this right now, okay? And right now you can see here, I'm only allowing Hermes to do a search. If I asked it to do a crawl, it would fail. If I asked it to scrape this website, it would, using the firewall, the Firecrawl MCP server or tool, it would fail. Okay. Now what I had to do is I actually had to add this tool into the configuration of the Hermes agent. Okay. So I had to exec into the pod, and I actually had to do the setup and do some configuration. One of the things you can do is you can actually do that in your code, right? Which I actually also have, and I'm on a different PC, so I can't show you the code in the repository that sits on. Essentially, I have a complete coding, which I've uploaded to my GitHub, and I'll share with you guys so you can see how this is all configured. Now, Langfuse is not part of that yet. I haven't added that in there. I've just been playing with Langfuse for now, and then we'll add it back in so you get a full stack with the Langfuse integration for your agent observability. Okay, so let's test this out. Actually, I'm sorry, let's go to Langfuse now. So you can see here I have Langfuse set up. I know it's probably really small. And I'm looking at tracing. And probably these logs, these errors that you see are probably from that ClickHouse implementation failing. I have to do some more troubleshooting on that. But essentially this works. If I go home, right, I have a dashboard. You can see here I have model costs. This is probably why I'm not seeing any costs here, is the ClickHouse is not working. But essentially we will manage, Langfuse will determine model cost per token. And what we're doing here is you can go in and you can set up the per token costs manually if you want. So you create a project, right? You can see here I have in my matrix lab, I have organization matrix lab, and I have a project called Hermes Demo or Hermes Neo, excuse me. And in Hermes Neo, I can now go in and I can set up my per token cost, right? What do they cost? And I can put that down, and now I can get a full visibility into kind of token economics, token costs within Langfuse. What I'm really interested in, right? And by the way, you do have 3 dashboards that are automatically created when you deploy this. You have a cost dashboard, a latency dashboard, and a usage management. The cost dashboard is not working right now. I think because of the ClickHouse, I have to double check on that. The latency dashboard is working, so you get latency of what is my latency, what's my P95 latency level, observations, what's my average time to first token, all of that. Okay. Now we provide some of this natively in Nutanix Enterprise AI as well, but this solution gives you more, full capability of tracing as well, right? And so we'll go back to the dashboards and we'll look at the usage management. And you can see here, I've done 50 traces so far through my testing, the total observation count, right? All of that. So these are just the built-in dashboards that come with Langfuse. Okay. Now there's another solution that's similar to Langfuse, uses the same kind of model, but it's more SaaS approach where you send the data to a SaaS solution. It's called Langsmith. Okay. So that may be something that you may want to use if you can use SaaS solutions that may be more beneficial to you, right? Because now you don't have to worry about the infrastructure side of it, right? The database, like all of the things that I've deployed, right, within Kubernetes, right? I don't have to, sorry, hang on. You won't have to deploy a lot of this, right? Like this will all be deployed on the back end of the SaaS solution, right? You're not managing this side of it. You're just consuming a service. Okay. So now you have dashboards. Now you have tracing, which is really what I want to get to. So I have to make this smaller. I'm sorry, guys. I know it's probably not going to be great, but I want to show you all of the things. So one of the things I found during this is, here's one. I did use the Firecrawl MCP. So basically, it gives you a full, right, preview of what the Hermes agent is about. This is kind of like all of the context, right, around the Hermes agent. And it's very large, right? And this goes to show you like how MCP and agents, right, use large context sometimes. Now you don't have to do that, right? That's why sub agents are very important. That's why you don't want to have one agent be kind of this overall, it does everything, because you'd be like, the context will be massive. So what you'll want to do is you want to have an agent that is in control of sub agents. And the sub agents have very little context. They do specific things, and they use specific smaller models to do those specific things to lower cost. Okay. And so the idea is not to have this one big agent, right, to do everything. And that's kind of how I had this set up, which is not best practice. Even though Hermes will spawn off sub agents to do specific things, it will do that. In my demo here, I'm only showing you kind of one large agent, right, which is not what you'd want to do. Now you'd want to have a large agent maybe manage all the sub agents, or it be your reasoning agent, right? Those things. And so you still would have probably a larger context. But again, what I'm giving you here is I'm giving you all of the preview of what's happening, right? The latency, the total tokens, right, in this request. And I think this request, my last request was, yep. So my last request was, give me something on, give me information on Nutanix Agentic AI capabilities. Okay. And it used the MCP Firecrawl tool to do that. And by the way, you can also get metrics back into the Firecrawl connector here, and you can see the requests coming in, what's being accessed, right? What API key is being used, what tools are enabled, right? And you can see that I have a bunch of successful requests. So if I go back here and let's just start a new request into Telegram, and I say, search the web and give me comparisons from a RTX Pro 6000 Blackwell Blackwell and RTX Pro 5000 Blackwell GPUs. Okay, you can see here, again, I know I'm treating this like a chat bot. Agents, you're going to want to have more automation, right? You're going to have more uh, autonomy, right? More capabilities, more tool calling, more direct access to maybe a CLI, right? To do some scripting, all of those things, right? Just look at this as the reason I'm doing this is to show you, okay, I'm doing this request and I'm going to show you the tracing, right? It gets back. So you can see here, it went out, used the Firecrawl MCP tool, and it came back and gave me a comparison of the RTX Pro 5000, etc. Now, let's go back into Langfuse and see exactly what happened. Okay, so if I go back into traces, all right, you can see here, the user is asking to compare, right? And so this is your initial ask. And you can see here that it used 30,639 tokens. Okay. You can get a log view of this, of exactly what happened, the output, right? The metadata, all of that. You can score it. I don't have scoring set up. Okay. So let's not get into that right now. You can see this in a formatted, right? And you can see this in a JSON backend, right? To see exactly what it looks like in JSON. All right. So you can see and trace exactly what this agent did. Extremely important, right? Extremely important. And then let's see here. Here's the out, right? So the completion was 400. So 33,123 tokens was the output, right? So just to ask that, because, and by the way, the reason why is because all this context was loaded in. Can you imagine? Right. Then it went through the reasoning. Right. You can actually go by and you can see the reasoning of what is actually happening with the agent. Right. And then it goes by and it says, what's the output? Let's look at the output. Right. So all of that is traced within Langfuse. Extremely, extremely valuable here, because what you're going to want to do is you're going to want to see the latency, right? You're going to want to see how many tokens were used. You're going to want to see exactly what the agent did, exactly what the agent did. So imagine that this is something watching over your employee's shoulder, looking at everything your employee did to take an action or to do a task, and then giving you a report back on that. That way you guys can go in and look at, okay, did it call the right tool? What was the latency to call the tool? Did it reason properly? Is there something I can do to limit tokens? What was the cost of this specific action, right? Because now I can take all that data and I can start fine tuning or fixing how I can optimize what the agent does. Remember, the goal is to allow the agent to do what it is you need to do, right? At the lowest cost, at the best accuracy, the lowest cost, right? And I wouldn't say best accuracy. You want it to be accurate, right? You want it to be repeatable. That's another thing too. You want your agents to be repeatable and accurate. Okay. And I haven't even put in a RAG or anything like that. This is something that you can add in with your data, right? This is just a basic chat bot. Let's just for all intents and purposes, just to show you guys what you get within Langfuse from a visibility perspective. Okay. And you can do prompt management, right? You can do playground. You can enter a message here, add an LLM connection. So if I wanted to, I can add an LLM connection to OpenAI, right? And do prompt engineering, right? You're going to put your user message in. You want to see the output, right? You want to look at prompts. You can create a prompt. You can edit UIs. You can compare metrics. You can give scores and evaluations. Extremely important. You can create an evaluator. You can use an LLM as a judge evaluation, right? So say you have a very large language model, right? Very smart, intelligent language model, and you're testing against small language models to see how they would do. Or you're using a frontier language model, but on-prem you're using an open source, language model. You want to test and see how the traces work, right? How the evaluations work, right? The accuracy, all of those things. You have data sets. You can create data sets and experiment with your data sets, human annotation. So all these things you can do within Langfuse. Extremely powerful. Okay. And then of course you can go back and you're supposed to be able to get kind of a cost model too. Again, that's not working right now, so I couldn't show you that. But essentially, the idea is to understand like the latency, the tokens, the cost. Is my agent doing what I intended it to do? Do I need to go back in and do some fine tuning on the code? Do I need to do some more optimizations, right, around agents, right, and what it's supposed to do? All those things. Okay, so this is kind of just like a very high level overview of the environment, right? And, kind of my test environment to kind of give you an idea of how these, how Langfuse can be integrated into your agentic environment to give you full visibility. Nutanix gives you some visibility. I'm not saying that we don't. And you can go into the Kubernetes layer and you can get a lot. I mean, you can get all the logs. You can, push the logs into other areas, right? You can go to Grafana if you want. So for example, I can go and create a Loki dashboard in Grafana and have those logs, have a dashboard for the logging, all of that. But, you don't want your consumers doing that. You want your consumers to have access to environments, right, that are not hosting the back end. That's the idea. You don't want your consumers to be accessing the infrastructure plane, right, unless they're only deploying something, right? And then you can automate that. You want your consumers looking at the output of what they built from an agent or AI app perspective, okay? And then your SREs should get access to Grafana, Loki, right? The logging, the Kubernetes layer, right? Your Kubernetes platform people should get access to the Kubernetes layer, right? The infrastructure team should have access to the infrastructure that this is all running on, right? That's how it should be kind of laid out from a operations perspective, okay? And that's kind of the goal. The goal is to, you ever hear TMI? You probably heard this all the time. Sometimes we give people too much information. You want to give them enough information for their role, for their specific role, enough access and enough information for their specific role so they can do their job effectively. Okay. And so that's the idea of, removing the concept of, having AI, data scientists or AI people connecting to, infrastructure backends, unless it's completely gated. And what you can do, by the way, within Nutanix Kubernetes platform, you can gate and give fine-grained RBAC, et cetera. But you want to have a system that can bring it all together, right? From token usage, from tracing what the agent's doing, from latency perspective, from prompt engineering, all of that. Langfuse is one of those tools that can get you there. So I hope you enjoyed the podcast today. I know I was talking a lot. It's a lot of information to give you. I will put this on my website. It will be here under the, if I go to the main site here, if you go to unknowntech.com or unknowntechio.com or unknowntechio wordpress.com, it will forward. So Cloudflare will forward to this. You go to live streams and podcasts, click on this, and then you'll see all the podcasts I've done. And you'll be able to click the link and play them. It's just basically a link to my YouTube. So when this is done, this will be posted to YouTube. And then this will be episode 23 down here. And if you want to look at any other episodes, you can actually go back and click in here. Again, if you want to know about what I've set up for my lab, episode 20 and 21 are my current portable agentic platform lab. If you want to know more about my home lab, you can see episode 18. This is the full lab here, except this has changed over to the left. I'm using the MSO2 Ultra. You can see the DGX Spark, but you'll get an idea of the Florida mini rack build that I've done, which gives you the ability to do a lot of the things I do. Okay. So I hope you have a great rest of the weekend. And I hope summer's treating you good. I hope you're having great weather and you're able to spend time with your family. That's extremely important. And I hope these sessions are valuable to you. If not, or if you have feedback, please don't hesitate to reach out to me on LinkedIn or directly, right? I give my contact information. I'd love to hear your feedback. If you have ideas or you want to see more things, please let me know. Or if you're an expert and you want to be a part of the podcast, and you want to come on as a guest, I would love to have you on. right? I love to bring other people on from different areas. I want to start doing that more. I did it one time, and I want to do that more and more, especially for folks that are outside of Nutanix, so we can talk more about, AI holistically and not just from a Nutanix lens, right? It has to be from a holistic lens, right? All right, so I hope you have a great day, and I'll see you in the next one. Remember, the next one's going to be on the Nutanix Validated Design for AI, which will get into more enterprise level architecture and how we design and validate the platform to give you options like this. All right, so again, have a great day. I'll see you in the next one.
Hey, broke down bones, dust in the air, eyes to the ground, no one cares. Empty streets, whispers bite, lost my way in the dead of night. Hey. Rock bottom, yeah, I felt the crack. Time to rise, time to fight back. Climbing up, no chains, no lie. Gonna find my way back to the top. Gonna find my way back to the top. Scrape knees, blood on my hands. Falling feels like sinking in sand. Echo scream, can't drown them out. Heartbeats loud, I'm done with doubt. Rock bottom, yeah, I felt the crack. Time to rise, time to fight back. Climbing up, no chains, no lie. Gonna find my way back to the top. The shadows laugh, but they don't own me. I've burned before, now I'm free. Fire in my veins, ashes in the wind. I lose, I learn, I begin again. Rock bottom, hit the